Hey there, folks. All right, here is a little summary of what we're going to do today, day 3 of nuclear chemistry. I'm going to give you a few notes about half-life. You are going to do a video worksheet about half-life. You're going to work on some of the assignments for some practice problems, and you'll have some time for some review for the unit quiz. That'll include some quiz yourself slides that are on Google Classroom. Maybe you want to make some flashcards, etc. All right, here we go. First up, that warm-up that you just did. If you don't have the warm-up, just read along. What's fission? What's fusion? The key difference between fission and fusion, they're both artificial types of artificial transmutation. They both create large amounts of energy, like any nuclear reaction. But in fission, we're breaking large nuclides or large isotopes into small. In fusion, we're fusing or slamming together smaller nuclides to make larger nuclides. Okay, so in this diagram, is this fission or fusion? Well, we're slamming one neutron into this larger nuclide, and it's breaking apart into two smaller ones. So this has to be fission. Okay, we're breaking apart one large one into two small ones. That would be fission. Okay, question 4. Which one is a fission reaction? The first one. We're breaking a large nuclide into two smaller nuclides, whereas this would be fusion, slamming together two smaller things to make a larger thing. And this is just some random natural transmutation, decay of a radioactive isotope, carbon-14. Fusion, slamming together two small nuclides to make a larger nuclide. That's fusion. And number 6, I recommended that on page 44 you memorize these radioisotopes and what their uses are by humans. And so in nuclear reactors, it's uranium-235. Okay? All right, moving on. Half-life. You learned about it in earth science. Here's just a little one-sentence recap. Half-life is the time it takes for half the atoms in a radioisotope sample to decay. Here's what we're going to do. You've got a little chart on a half sheet of paper, and hopefully you've got probably a pink piece of 8.5 by 11 paper. We're going to go through just a little folding thought exercise as we try to just wrap our brains around half-life. Okay, so we've got a radioisotope with a half-life of 3 days, and we're starting with 80 grams of our radioisotope. Doesn't matter, it's an imaginary radioisotope. Okay, so this whole piece of paper represents 80 grams of our isotope. That is what we are starting with. Okay, and so since our half-life is 3 days, when 0 half-lives have elapsed, well, that's when we're at time 0. Okay, so when we're at time 0, we have all of our radioisotope left. So the fraction that's left of our radioisotope is 1 whole. Okay, that means we've got 100% of our radioisotope is still unchanged. Okay, so that means we've got 80 grams. That's what we start with. At time 0, 0 half-lives elapsed, we got everything. It's all 80 grams is our radioisotope. Okay, 1 half-life would take 3 days. Why? Because the radioisotope that we have has a half-life of 3 days. Okay, so after 1 half-life, how much is left? We've got 1 half left. Okay, and so what that means with your paper is fold it in half, and then we just draw a big X through this. This half has decayed and transmutated into something else. We've got half of it left, so we've got 50% left, or 40 grams of our original isotope is left. This is 40 grams. It was 80, now it's 40. Okay, 2 half-lives elapsed. How long is that? Well, that would be 6 days. How much is left? Half of half. That means we've now got 1/4 of our isotope left, or 25%, or 20 grams. That means you take the paper, fold it in half again, and that means this much has decayed. Okay? That's 2 half-lives. 3 half-lives? Well, we fold it in half again, and this much has decayed. When would that be? Well, 3 half-lives would be 9 days, and that would mean that there's only an 1/8 left of our original radioisotope. That's 12.5%. Mr. Young, how'd you do that in your head? I'm smart. 20 grams becomes 10 grams. Okay, Now, the next half-life, we fold that paper again in half, and because half of it has now decayed, that's all we've got left. That's 4 half-lives. That's 12 days. 4 times 3 is 12. That means we're down to 1/16. That means we're at 6.25% left. That's 5 grams. Let's see how much further we can get. Oh, fold it again. Half of it has decayed. Only got half left. That's 15 days, because 5 times 3 equals 15. We're at 1/32. That's 3.125. Mr. Young, you are amazing at mental math. And we're at 2.5 grams. Okay, let's see if we can get one more. Yes, we got one more. Okay, fold that in half. This is all we've got left. 6 half-lives would be 18 days. That's 1/64 left, or that's 1.5 plus 1.5625. Hope that's right. I think it's right. Percent. And we're down to 1.25, and I think that's as far as we can go. I don't think I have another line. Yep, that's it. That's as far as we go. So we don't get to 7 half-lives. Okay, so that's just taking you through kind of a visualization of what half-lives mean. Another way to think about it is this. At 0 half-lives, we've got the whole thing. We've got 100% left of our radioisotope. That's what we start with, 100%. At 1 half-life, we got a half left. That's 50% left. 2 half-lives is a fourth. 3 half-lives, we've got an eighth. Whoops, that's supposed to be a 4 half-lives. That should be a 4. Okay, 4 half-lives is 1/16. One thing you may notice is this is 1/2 to the 0 power. This is 1/2 to the 1 power, the first power. This is 1/2 squared. So it's 1/4. This is 1/2 to the third. This is 1/2 to the fourth. In case you're math-minded, that's one other way to think about this. Okay? All right. I'm going to pause right now and pick this up on the next video.